Hello, my dear students. Today in this class, we will learn how to solve a system of linear equations by using matrix method. So, let's start. Consider a system of linear equations a11 x1, a12 x2 plus a1n xn equal to d1, a12 x2 plus a11 x a21 x1 plus a22 x2 plus a2n xn equal to d2. Next, a n1 x1 plus a n2 x2 plus a nn xn equal to dn. It can be written in the form a x equal to b, where a equal to a11 a12 a1n a21 a22 a2n an1 an2 ann, comma x equal to capital X equal to x1 x2 x3 xn and b equal to d1 d2 dn. A system of linear equations it can be written in a form ax equal to b, where a equal to this and x equal to this and b equal to this. To solve this system of linear equations, first we will find inverse this system of linear equations. To solve this system of linear equations, first we will find determinant of a. Step 1, determinant of a. First we will find determinant of a. Next, step 2, if determinant of a not equal to 0, first we will find determinant of a. Next, step 2, if determinant of a not equal to 0, then the system of linear equations is consistent. Consistent means the solution exists. And it has a unique solution. If determinant of a not equal to 0, then the system of equations is consistent and it has a unique solution. Next, step 3, if determinant of a equal to 0, then the system of linear equations is inconsistent, then it has no solutions. Remember, to solve a system of linear equations, first we will find determinant of a. Step 2, if determinant of a not equal to 0, then the system of linear equation is consistent, then it has a unique solution. Step 3, if determinant of A equal to 0, then the system of linear equation is inconsistent and it has no solutions. Now we will discuss some numerical problem from exercise 4.6. Before starting this exercise, remember consistent system and inconsistent system. Consistent system, a system is said to be consistent if the solution exists, and a system of linear equation is said to be inconsistent system if the solution does not exist. Now we will discuss exercise 4.6. First question, examine the consistency of the system of equations. Examine the consistency of the system of equations. Question number 1, given x plus 2y equal to 2, 2x plus 3y equal to 3. Already we have learned a system of linear equations can be written in the form ax equal to b. Already we have learned a system of linear equations can be written in the form ax equal to b. Therefore, the given equations linear equations can be written in the form ax equal to b, where a equal to the coefficient of x 1, the coefficient of y 2. For the second row, the coefficient of x 2, the coefficient of y 3. A equal to 1, 2, 2, 3. X equal to xy and b equal to the constant term 2, 3. Now determinant of A is equal to 1, 2, 2, 3 is equal to 3 minus 4 equal to minus 1, which is not equal to 0. Now determinant of A is equal to minus 1, which is not equal to 0. Therefore, the given linear equations is consistent. Since determinant of A is not equal to 0, therefore the given linear equations is consistent. Next, question number 3. Question number 3, given x plus 3y equal to 5 and 2x plus 6y equal to 8. The given equations can be written in the form ax equal to b, where a equal to, for the first row, the coefficient of x is equal to 1, the coefficient of y is equal to 3, for the second row, the coefficient of x equal to 2, the coefficient of y equal to 6. X equal to, capital X equal to xy and b equal to 5, 8. Now determinant of A is equal to 1 3 2 6 is equal to 1 into 6 6 2 into 3 6 equal to 0. Here determinant of A equal to 0. Therefore the given linear equations is inconsistent because determinant of A is equal to 0. Next question, solve the system of linear equation using matrix method. Question number 7. Next we will discuss question number 7. 5x given 5x plus 2y equal to 4. 7x plus 3y equal to 5. Solve the system of linear equation by using the matrix method. Solve the system of linear equation by using the matrix method. We know that a system of linear equations can be written in the form Ax equal to b. Already we have learned a system of linear equations can be written in the form Ax equal to b. Therefore, the given equations can be written in the form Ax equal to b, where A is equal to for the first row, the elements are the coefficient of x is equal to 5, the coefficient of y is equal to 2. For the second row, the coefficient of x equal to 7, the coefficient of y equal to 3. Capital X equal to xy and capital B equal to the constant term 4 5. We know that to solve a system of linear equation, first we will find determinant of A. First step we will find determinant of A. Next step, if determinant of A is not equal to 0, then the system of linear equation is consistent and it has a unique solution. Third step, if determinant of A not is equal to 0, then the system of linear equation is inconsistent and then the system of linear equation have no solutions or does not exist. Therefore, first we will find determinant of A. Determinant of A is equal to 5 2 7 3. This is equal to 5 3 15 minus 14 equal to 1, which is not equal to 0. Therefore, here determinant of A is not equal to 0, is equal to 1. Therefore, the system of linear equation is consistent and it has a unique solution. Next, here Ax equal to b, then we have x equal to a to the power minus 1 into b. The given equations can be written from Ax equal to b. Ax equal to b, then we have x equal to a to the power 1 into b, inverse matrix of A into b, where remember x equal to a to the power minus 1 into b, where a to the power minus 1 into a to the power minus 1 is equal to 1 by determinant of A into adjoint of A. Already we have learned a to the power minus 1 equal to, or inverse matrix of A is equal to 1 by determinant of A into adjoint of A. So, to find a to the power minus 1, first we will find out adjoint of A. First we will find out adjoint of A. For adjoint of A, we will find the cofactor of A. Cofactors of A. A11 is equal to here A is equal to 5 2 7 3. A11 is equal to, we have already learned, A11 is equal to minus 1 whole to the power 1 plus 1 into M11, minus 1 whole to the power 2 plus 1 M11 is equal to 3. In previous class we have learned how to find cofactor or minor of a matrix. A12 is equal to minus 1 whole to the power 1 plus 2 into M12 is equal to minus 1 whole to the power 3 into M12 is equal to 7. This is equal to minus 7. A21 is equal to minus 1 whole to the power 2 plus 1 into M21 is equal to minus 1 into M21 is equal to 2 equal to minus 2. A22 is equal to minus 1 whole to the power 2 plus 2 into M22 plus 1 M22 is equal to 5. Therefore adjoint of A113 A12 minus 7 A21 minus 2 A22 5 transpose is equal to 3 minus 7 minus 2 5. We have adjoint of A is equal to 3 minus 2 minus 7 5. Adjoint of A is equal to 3 minus 2 minus 7 5. Next we will find inverse of A, inverse matrix of A or A to the power minus 1. Therefore A to the power minus 1 is equal to 1 by determinant of A into adjoint of A. 1 by determinant of A is equal to 1. Therefore 1 by 1 into adjoint of A equal to 3 minus 2 minus 7 5. This is equal to 3 minus 2 minus 7 5. Therefore A to the power minus 1 equal to 3 minus 2 minus 7 5. Since Ax equal to B, therefore x equal to inverse matrix of A into P. X equal to xy equal to inverse matrix of A. Inverse matrix of A equal to 3 minus 2 minus 7 5 into B. B is equal to 4 5. xy into first row multiply first row first column 3 4 are 12 minus 10. Next multiply first row second row first column minus 28 plus 25 xy is equal to 12 minus 10 2 minus 28 plus 25 minus 3. Therefore here this and this matrix are equal. Therefore we know that if two matrices are equal, then the corresponding elements are equal. Therefore x equal to 2 and y equal to minus 3. X equal to 2, y equal to minus 3. The required answer is x equal to 2 and y equal to minus 3. Remember, to solve a system of linear equations by using matrix method, first we will find determinant of A. First step we will find determinant of A. Next step, if determinant of A not equal to 0, then the system of linear equations is consistent and it has a unique solution. Or determinant of A equal to 0, then the system of linear equation is inconsistent and it has no solution or does not exist. If the system is consistent, then first we will find out inverse matrix of A. And we put A to the power minus the inverse matrix of A and B, the value of inverse matrix of A and the value of B in these equations. X equal to A to the power minus 1 into B, then we will find the value of X and Y. We will discuss another question. Question number 11. Question number 11. 2x plus y plus z equal to 1 by 3. Oh, sorry, only 3. Two x plus y plus z equal to 1 and x minus 2y minus z equal to 3 by 2 and 3y minus 5z equal to 9. Given a system of linear equations, 2x plus y plus z equal to 1, x minus 2y minus z equal to 3 by 2 and 3y minus 5z equal to 9. These equations can be written in the form Ax equal to B. These equations can be written in the form Ax equal to B. The given equations can be written in the form Ax equal to B, where A equal to for the first row, the coefficient of x is 2, the coefficient of x is 2, the coefficient of y is equal to 1, the coefficient of z is equal to 1. For the second row, the coefficient of x is equal to 1, the coefficient of y is equal to minus 2, the coefficient of z equal to minus 1. For the third row, the coefficient of x is equal to 0, the coefficient of y is equal to 3, the coefficient of z is equal to minus 5, and capital X equal to x, y, z, and b equal to 1, 3 by 2, 1, 3 by 2, 9. To solve this equation, this pair of these linear equations, first we will find out determinant of A. So, determinant of A is equal to 2, 1, 1, 1, minus 2, minus 1, 0, 3, minus 5. B equal to 1, 3 by 2, 9. Now, determinant of A is equal to determinant 2, 1, 1, 1, minus 2, minus 1, 0, 3, minus 5 is equal to, now expanding by using using first row, then we have, now expanding using first row, and we have 2 into 10 plus 3 minus 1 minus 5 minus 0 plus 1 3 plus 0. This is equal to 13 minus 5 plus 3, 26 plus 5 plus 3 equal to 34, which is not equal to 0. Here determinant of A is equal to 34, which is not equal to 0. Determinant of A is equal to 34. We have determinant of A is equal to 34. Next, we will find adjoint of A. For adjoint of A, first we will find out cofactor of this given matrix. cofactor. Now cofactors of A. Cofactors of A. Therefore, A11 is equal to minus 1 whole power 1 plus 1 into M11 is equal to M11 minus 1 whole power 2 equal to plus 1 into M11, the minor of the element A11. Then we have minus 2, minus 1, 3, minus 5. This is equal to 10 plus 3 equal to 13. Next, A12 is equal to minus bracket minus 5 minus 0. This is equal to 5. A13 equal to plus 3 minus 0 is equal to 3. Next, A21 equal to minus 5 minus 3 equal to plus 8. Minus 5 minus 3. Next, A22 is equal to minus 10 minus 0. This is equal to minus 10. A23 is equal to 6 minus 0. This is equal to minus 6. A31 is equal to minus 1 plus 2. This is equal to 1. Next, A32 is equal to minus 2 minus 1 minus 3. Minus 2 minus 1 minus 3. This is equal to plus 3. A33 is equal to minus 4 minus 1 minus 5 is equal to minus 4 or minus 5. Therefore, adjoint of A11 is equal to 13. A11 is equal to 13. A12 5. Next, A13 3. A21 8. A22 minus 10. A23 minus 6. A31 1. A32 3. A33 minus 5. Transpose. This is equal to 13 5 3 8 minus 10 minus 6 1 3 minus 5. The adjoint of A is equal to this. Adjoint of A is equal to 13 8 1 5 minus 10 3 3 minus 6 minus 5. Next, we will find inverse of A. Inverse of A is equal to, we know that inverse of A equal to 1 by determinant of A into adjoint of A. 1 by determinant of A, we know that inverse of A equal to A to the power minus 1, or inverse matrix of A is equal to 1 by determinant of A into adjoint matrix of A. 1 by determinant of A is equal to 34. Therefore, here 34 into adjoint of A equal to 13 8 1 5 minus 10 3 minus 6 minus 5. Since x equal to inverse matrix of A into B, already we have learned x equal to inverse matrix of A into B. Therefore, here x is equal to xyz. X is equal to capital X is equal to xyz, and inverse matrix of A is equal to 1 by 34 into 13 8 1 5 minus 10 3 minus 6 minus 5 into B is equal to 1 3 by 2 9. x, y, z. This equal to 1 by 34 into multiply first of first column. Then we have 13 1 the 13 plus 8 into 3 by 2, 8 into 3 by 2, 4 3 is 12 plus 9. 5 into 1 5 minus 10 into 3 by 2 minus 15 plus 27. Next 3 into 1 3 minus 9 minus 45. This equal to x, y, z equal to 1 by 34 into 35 plus 12 plus 9, 3 plus 2 5, 5 plus 9 14, 1 plus 2 3. Next 5 minus 15 minus 10 plus 27 equal to 17. Next 3 minus 9 minus 6 minus 45 minus 51. X, y, z. This equal to 34 divided by 34 1, 7 by 30, 17 by 34 equal to 1 by 2, minus 51 divided by 34 minus 51 divided by 34 is equal to minus 3 by 2. Therefore, x equal to 1, y equal to 1 by 2 and z equal to 3 by 2. This is the required answer. Here x equal to 1, y equal to 1 by 2 and z equal to minus 3 by 2. Thank you.